Hi guys, in this video we are going to solve the integral from 0 to pi over 4 of cos 2x into tan cube x. Before we start anything, let's think about how we can solve this problem. Let's start with the term tan cube x. We can obtain tan squared x from tan cube x. Tan squared x can be written as sec squared x minus 1. Let's substitute sec squared x as u. Now we have tan squared x equal to u minus 1. Now cos 2x. Cos 2x we can write as 2 cos squared x minus 1 using double angle formula. Cos squared x value we can write from the denominator as sec squared x. Since sec squared x equal to u, we can write cos 2x as 2 over u minus 1. So we can think of sec squared x equal to u guiding us to simplify this integral. Let's jump into the question. Let's substitute u as sec squared x. Differentiation with respect to x. Differentiation of the u we can write as du over dx. Differentiation of the sec x perfect squared we can write as 2 into sec x to the power of 1 into sec x tan x. After that, we can cross multiply denominator value dx. Sec x into sec x value we can get as sec squared x. Finally, we can subject dx as du over 2 sec squared x into tan x. Since u equal to sec squared x, we can write dx value as du over 2u tan x. Now we need to change upper limit and lower limit corresponding to u variable. U equal to sec squared x. When x equal to 0, sec 0 perfect squared. It is equal to 1. So u equal to 1. When x equal to pi over 4, u equal to sec pi over 4 perfect squared. It is equal to root 2 perfect squared. Then u equal to 2. Let's move to integration part. Now lower limit is 1, upper limit is 2. Instead of cos 2x value, we can substitute 2 over u minus 1. Instead of tan squared x value, we can substitute u minus 1. Instead of dx value, we can substitute du over 2u tan x. Now we can cancel out denominator value tan x and numerator value tan x. Denominator value 2 is a constant. So we can bring 1 over 2 outside of the integral. After that, we can remove the brackets. First one, 2 over u into u. Second one, 2 over u into minus 1. Third one, minus 1 into u. Last one, minus 1 into minus 1. Now we have 2 minus 2 over u minus u plus 1. Two plus 1 equal to 3. After that, we can multiply all the terms from 1 over u. First one, 3 into 1 over u. Second one, minus u into 1 over u. Last one, minus 2 over u into 1 over u. Then we can get the result 3 over u minus 1 minus 2 over u squared. Now we can consider integral sign separately. Next, we can bring constant value outside of the integral. Then we have 3 integral 1 over u minus integral 1 minus 2 integral u to the power of minus 2. One over u integral is equal to ln modulus u. integral 1 equal to u. U to the power of minus 2 integral we can write as u to the power of minus 1 over minus 1. Finally, we need to substitute upper limit and lower limit for these answers. First one, ln u, upper limit 2 minus lower limit 1. Next one, u, upper limit 2, lower limit 1. Last one, upper limit 2, lower limit 1. ln modulus 2 value equal to ln 2. ln modulus 1 equal to ln 1, it is equal to 0. 2 minus 1 value equal to 1. 1 over 2 minus 1 over 1 equal to 1 minus 2 over 2. Then we can simplify minus 1 plus minus 1. It is equal to minus 2. So we have final answer as half within bracket 3 ln 2 minus 2.